We talked about relativity back in chapter 3. Save one thing, and that's this. Here's the most famous equation in the world, and here's where it comes from. Einstein developed this theory about talking about space and time. And ultimately, he did this because he was interested in electromagnetism, which is a whole other story. But he developed this whole theory of space and time. One of the things that comes out of it is this. If you write down an expression for energy of an object, it's not the whole 1/2 mv squared thing. It turns into this. It's equal to mc squared divided by the square root of 1 minus u squared over c squared. And the 1 minus u squared over c squared, square root of that quantity, that's something you see in relativity in terms of relating space variables, time variables. That's the whole time dilation, length contraction thing. Shows up again here with energy. U is the speed of an object. So the total energy of an object of mass m moving at speed u, this equation right here. If I take this equation and I put in object not moving, object at rest, u equals 0, I get E equals mc squared. So it says an object sitting at rest has energy purely as a consequence of the fact that it has mass. Okay? And that was kind of a big deal when it was proposed, because this is a kind of an odd notion that you can take mass and energy are kind of like interchangeable in some ways. You can take energy and you can turn it into mass. You can take mass and you can turn it into energy. Objects have energy as a consequence of just having mass. And if you can get rid of the mass, you can get rid of the energy. How can you get rid of mass, you say? Oh, heavens to Betsy, I'll show you. You can make something called antimatter. Oh, as a matter of fact, there's antimatter naturally occurring in nature. You can measure it in cosmic rays. A certain fraction of the charged particles that strike the Earth's upper atmosphere are antiparticles. A positron is an anti-electron. It's identical to the electron, except instead of having a negative charge, it has a positive charge. Okay? So if you take an electron plus a positron and you bring them together, they can spontaneously annihilate. They destroy each other because there's no charge. One's positive, one's negative. There's no charge. And there's other conserved quantities that will vanish as well. Positron plus electron, bring them together, they annihilate. What are you left with? Energy, just energy. They'll completely annihilate. Or you can take energy, and you can use energy to create an electron-positron pair, because you can create them together. This is a picture of a gamma ray coming in, striking a nucleus, and making an electron and a positron. And when they have opposite charges, we can tell they have opposite charges because they're following curving paths in magnetic fields. And so gamma ray comes in, makes a pair consisting of an electron and a positron. One's positive charge, one's negative charge. They spiral off in opposite directions. You can turn matter into energy. You can turn energy into matter. You can turn them back and forth. And now people kind of accept this, but the time it was proposed, that was like crazy talk. Anyway, suppose you want to do this. You would like to give birth to an electron and a positron, and you're going to do that by making a high energy gamma ray that's going to like turn into those. What's the minimum energy gamma ray you would need to do this? We can calculate it. And the way we calculate it is this. We begin with the most famous equation in the world, E equals mc squared. E is the energy of the gamma ray that I need. M is the amount of mass that I want to create. And I want to create an electron-positron pair. How much mass is that in terms of the mass of the electron? 2 times, because a positron has the same mass as an electron. So this is 2 times the mass of the electron. So the energy that's required is 2 times the mass of the electron times c squared. Well, the mass of the electron is 9.1 times 10 to the minus 31st kilograms. C is the speed of light, 3.0 times 10 to the 8th meters per second. And so the energy is just this. I have everything I need in the equation, and I can calculate it in terms of joules. But we don't want it in joules. We want it in mega electron volts. So calculate it in terms of joules, convert it to electron volts, and if you convert it to electron volts, you get 1.0 times 10 to the 6th electron volts, or 1.0 mega electron volts. So it takes a gamma ray that has an energy of 1 mega electron volt. Can gamma rays have energy that big? Oh yeah, oh yeah. So it's not a big deal. And this happens. This happens a lot. As a matter of fact, it's happening inside you because there's like gamma rays from like radioactive substances that are radiating you, and when they hit atoms in your body, they can give rise to these electron-positron pairs. And so not only can this happen, it is happening. It's happening inside you as we speak. Crazy.